Tonight, we turn our gaze away from the distant stars, away from the grand questions of cosmic beginnings and ultimate ends. Instead, we will look down under our own feet to ask something simple, yet profoundly unsettling. What if we are not the first to think, to build, to explore this world? What if, long before the first pyramids were raised, long before satellites traced their silent paths across the sky, another civilization was here? I do not speak of mythical continents lost beneath the waves or of visitors from other worlds. I speak of something homegrown, a biological intelligence that arose on this planet, achieved a measure of complexity, and then somehow vanished. This civilization would have lived and died so very long ago that the planet itself may have completely forgotten its existence. This may sound like the premise for a work of science fiction, and in some ways it is. But it is also a serious scientific question. It is a question that has been quietly considered in geology laboratories and at cosmology conferences for a number of years. The idea is not that we might one day unearth skyscrapers beneath the Antarctic ice or find smartphones embedded within ancient seams of coal. The truth is far more subtle. The real question is this: if an advanced civilization had existed millions of years ago, would we even be able to tell? Would any of its traces have survived the slow, relentless grinding of Earth's geology? Or would everything, their cities, their tools, their language, even their very bones, have been recycled back into rock and soil? Would they now be utterly indistinguishable from the natural world? We must understand just how much time we are truly dealing with. We must also appreciate how adept this planet is at wiping the slate clean. Only then can we begin to ask whether someone or something came before us. We must slow our thoughts to the patient pace of plate tectonics itself. When we speak of ancient history, our minds typically drift back a few thousand years. We think of the pharaohs of Egypt, the builders of Stonehenge, or the earliest known scripts that were carefully etched into clay tablets. Even when we reach back to the very dawn of human civilization, we are still only traveling back approximately 10 or 12,000 years. In the grand scope of geological time, this is but a momentary blink of an eye. This period feels to us like the deep past, a time vast enough to fill entire libraries with its mysteries, its debates, and its endless speculations. Yet it is closer to our present moment than to almost anything else that has ever happened on this planet. But the Earth is old. It is staggeringly, almost incomprehensibly old. We are not speaking merely of millions of years. We must think in terms of billions, approximately 4.5 billion years, with a margin of a few hundred million. For the vast majority of that immense span of time, there were no humans. For most of it, there were not even any mammals. And for a great deal of it, there was no life on the land at all. Life spent an extraordinary amount of time swimming, or waiting, or evolving in microscopic obscurity. And yet this was the period when most of Earth's story was written, layer by silent layer, rock by patient rock. The planet does not keep a diary. It does not preserve everything with equal care. Wood inevitably decays, metal rusts, and bones eventually dissolve. Time does not just pass, it acts upon the world. Time buries and it melts, it crushes, shifts, and ultimately, it erases. Great mountains rise and are then crumbled back into dust. Oceans open and then close. Entire continents drift, collide with one another, and then break apart. Every few 100 million years, the very face of our world changes completely. When you begin to see it this way, you understand that evidence is not merely lost. The simple act of surviving for more than a few million years is an extraordinary event in itself. So let us engage in a thought experiment. Let us imagine that perhaps 100 million years ago, another intelligent species evolved. This was long after the age of dinosaurs began, but also long before it came to its end. Perhaps this species was upright, or perhaps it was not. Maybe it was land-based, or maybe its home was in the water. It is possible it never built with stone or metal, for the simple reason that it never needed to. It might have possessed a form of technology that we ourselves would not even recognize. It might have lived for a time, developing what we could call a culture or a society, and then something happened, a catastrophe, or just the slow, quiet fade of time. It disappeared. And now we arrive millions of years later asking if we would even know that it had ever been here at all. Because there is a hard truth we must face. We are not nearly as permanent as we so often like to think we are. Our towering skyscrapers, our endless highways, our libraries and our satellites, none of them are built to survive the crushing weight of geological time. Leave a modern city to its own devices for just a few centuries, and nature will reclaim it. After a few thousand years, it is already difficult to see what was once there, but after a few million years of erosion, tectonics, and subduction, the surface of the Earth itself has changed. What was once land may now be the floor of the sea. This is not science fiction. This is based on what we have learned from the fields of geology and archaeology. Traces of even recent prehistoric human activity are incredibly rare. The Earth is a remarkably efficient recycler. Consider the fossil record. It is spotty at the very best. This is not because life was not abundant, but because the conditions required for fossilization are exceptionally specific and rare. Most organisms that die are never fossilized. To become a fossil, an organism requires a rapid burial, the replacement of its organic matter with minerals, and then protection from erosion. And after all that, one must be lucky enough for that rock to survive, become exposed, and then be found. The problem grows exponentially when multiplied by tens of millions of years, and it is not just a matter of bones. Buildings, artifacts, and tools, even those crafted from metal, do not last forever. Most metals will eventually corrode. Most plastics break down, especially when exposed to sunlight or buried underground. Even our formidable concrete, if left unprotected against the elements, will eventually crumble back into dust. It is a simple matter of time. So, if a civilization had existed in the distant past, especially one that did not leave behind vast quantities of stone structures, we might never have any knowledge of its existence. The traces would be entirely gone. You might be wondering if anyone has ever given this idea serious consideration. The answer to that question is yes. In 2018, two scientists named Gavin Schmidt and Adam Frank published a paper exploring this very concept. They were not proposing that such a civilization actually existed. Instead, they were asking a more fundamental question. How would one even begin to detect it if it had? They named their idea the Silurian Hypothesis. The name was a somewhat cheeky reference to a fictional race of intelligent reptiles from a British science fiction program. But their real question was one of methodology. What kinds of traces would an industrial civilization leave behind? What would be left in the geologic record after millions of years had passed? And could it be possible that such traces are already there in the rock, having been misinterpreted as something else entirely? They focused their attention on markers, on chemical signatures and anomalies. They considered things like carbon isotope ratios, unusual concentrations of rare elements, or synthetic molecules that do not occur naturally in the world. They were thinking like detectives who cannot find a body, a weapon, or even a witness. They were hoping the patterns left behind might still tell a story, and in doing so they raised a rather uncomfortable possibility. Perhaps the absence of evidence is not actually evidence of absence. Perhaps this is simply what things look like when a planet completely resets its surface every few 100 million years. Civilizations do not vanish cleanly. They leave behind waste. Their use of energy, their agriculture, their mining, and their manufacturing all leave fingerprints upon the planet. But fingerprints, as we know, can fade over time. If a previous civilization had gone through its own industrial age, or something equivalent, would we still be able to see the effects? Would they appear in climate records, in sediment cores, or in the composition of ancient rocks? Maybe, or maybe not. Even now, our own impact is being written into the geological record. This proposed new epoch is sometimes called the Anthropocene, a name for a new geological age marked by the influence of humanity. Plastic is in the oceans, concrete is in the soil, and nitrogen fills the atmosphere. There are radioactive isotopes left over from nuclear tests. If future scientists were to dig into our present layer, they might find these markers. The real question is, how long would those markers last? And how visible would they be if millions of years were to pass before anyone ever came looking for them? This is not just some idle speculation. Thinking in this way helps scientists to test the very limits of their methods. It is about understanding not only what we find, but also what we are most likely to miss. The geological record, you see, is full of gaps. Some periods of history are very well preserved. Others have been almost entirely erased from the record. Erosion can remove layers of sediment that took millions of years to build. Tectonic activity can fold, fault, and bury entire regions. Then there is the ocean, which covers more than 70% of the planet's surface. It hides countless secrets beneath miles of water and sediment. Most of the Earth's surface is, geologically speaking, quite young. This means it has been resurfaced or altered within the last few 100 million years. Even the floor of the ocean gets recycled through a process known as subduction. Old seafloor is pushed under continental plates and melted back into the mantle. If an ancient civilization had built anything near a coast, or on an island, or in a region that is now submerged, those traces might be long gone. We are here now, building and recording and observing our world. We often wonder if we are alone in the universe, but we rarely ask ourselves if we have ever truly been alone on this planet. Perhaps the distant past was quieter than we imagine, or perhaps we have simply lost the ability to hear its voice. Before we can look for lost civilizations, we must first decide what it is we are looking for. What exactly is a civilization? And what characteristics would make it count from a scientific point of view? In our daily conversations, we tend to think of civilization as an upgraded version of society. We imagine cities, writing, governments, and perhaps a glittering skyline. But this is a very narrow and modern point of view. Even within human history, civilizations have looked wildly different from one another. Some built vast cities with towering monuments and extensive roads. Others left almost nothing behind but their language and the patterns of their land use. In the fields of archaeology and anthropology, the definition becomes more careful. Civilizations are usually identified by a collection of specific traits. These traits include urban centers and specialized forms of labor. They also include centralized authority or governance, surplus agriculture, and organized religion. Social stratification, the development of writing, and long-distance trade are also among the key indicators. But not all civilizations will tick every single one of these boxes, and some of them accomplish these things in ways we might not expect. So when we discuss the possibility of a forgotten civilization, we must broaden our thinking. We are not necessarily looking for giant pyramids or for computer chips. We are looking for evidence of complexity, whether it is social, technological, or ecological. We are looking for things that do not happen by accident. We are searching for signs that suggest a group of beings organize themselves at a large scale over a long period of time. Their purposes would have gone beyond mere day-to-day survival. It is helpful to think of civilization not as a finish line, but as a spectrum. Somewhere between isolated survival and planetary scale engineering, there is a great deal of room for variation. A culture of tool users that created systems that outlasted individual lifespans would surely count. A species that learned to store knowledge to pass it on, and to deliberately modify its environment is significant. This may not sound like much to us now, but in evolutionary terms it is a monumental achievement. Let us consider an example that is closer to our own time. Take the ancient city of Çatalhöyük, located in modern-day Turkey. It is approximately 9,000 years old. It had no streets, no monuments, and no written language. It was simply a collection of densely packed homes built side by side with no doors. Its people entered their homes through the roofs. Yet, it is considered one of the earliest known urban settlements in the world. What matters is not the skyline, but the pattern. The coordinated building, the long-term settlement, the shared rituals and customs for burial. These are all signs of collective behavior that spanned across generations. If we go back even further in time, the clues become more subtle still. The earliest evidence of symbolic thinking in humans comes from tools, from pigments, and from carvings. These things imply planning, memory, and perhaps even belief. This was not technology in the modern sense of the word, but it was still technological within its own specific context. It is evidence that minds were beginning to work in more abstract and complex ways. So now let us imagine a civilization that existed not 10,000 years ago, but 10 million, or even 100 million. What would we truly expect to find? The answer depends a great deal on what they were like. If they built with organic materials such as wood, plant fiber, or animal products, those materials would simply not last. If they buried their dead with rituals but not with durable artifacts, we might find bones but miss the meaning behind them. And if they never developed a system of writing, or if they used a form that we do not recognize as writing, their stories might be lost completely. The situation becomes even more challenging if they did not live on land, if they spent most of their lives in environments that are not conducive to preserving fossils. Our chances of detecting them shrink even further. If a civilization arose in a rainforest, on a coastline, or in a swamp, its remains would be gone within centuries. We must also be careful not to project too much of ourselves onto this question. We are accustomed to seeing intelligence in the form that we ourselves exhibit. We look for language, for tools, and for cities. But intelligence does not have to look like us. A civilization might not be industrial at all. It could organize its society in ways that do not leave behind large material traces. It might communicate chemically or visually. And this brings up a very strange and difficult problem. If we were to find traces of such a civilization, would we even recognize it for what it was? Think of a termite mound. To us, it is a nest, a large pile of dirt. But in terms of its engineering, it is a marvel. It has internal climate control, systems for air circulation, and storage for resources. The termites build it collectively. Their colony behaves almost as a single, unified organism. If we did not know what we were looking at, we might mistake it for a natural geological structure. If you were to scale it up by a factor of 1,000, or bury it for a few million years, even that trace might completely disappear. So when we think about lost civilizations, we must learn to think like both archaeologists and biologists. We are not just searching for the ruins of ancient cities. We are looking for patterns and for anomalies. We are looking for disruptions in the geological record. And this could be unexpected concentrations of minerals or strange changes in sediment that do not match any known natural processes. Things that might suggest someone was here, doing something unusual. There is also the question of duration. How long would a civilization have to exist in order to leave a permanent mark? Geologically speaking, the answer is not very long at all. Humans have managed to transform the entire planet in just a few hundred years of industrial activity. In terms of sediment, this is barely a dusting, but the chemical impact of our presence is already measurable. Greenhouse gases, synthetic compounds, and nuclear isotopes are all markers of our time. Even if our species were to vanish tomorrow, some of those changes would remain detectable for tens of thousands, or perhaps even millions of years. So perhaps the better question is not whether a previous civilization existed, it is whether we are even asking the right questions to be able to detect it. We look for the signs that make sense to us. We search for fossils, ruins, and tools. But what if the true signs are stranger or smaller, or in places we have not yet thought to look? To answer this question, we must look at how the Earth itself behaves over immense spans of time, not just centuries, but entire epochs. If you wish to hide something forever, you do not need to bury it deep within the Earth or burn it to ash. You only need to leave it on the surface of this planet and wait. You must wait long enough for geology to do its work. The Earth is not a still and silent thing. It breathes and it shifts, it consumes. And almost everything that has ever been built on top of it will eventually disappear. We do not notice this in our everyday lives. We tend to think of landscapes as being permanent. Mountains seem eternal to us. Rivers seem as if they have always been in the same place. Cities feel as if they have always been exactly where they are right now. But geologists see something else entirely. They see motion in what appears to us to be solid. Over a long enough period of time, even the hardest rock will flow, or bend, or break. Even the tallest peaks will crumble. The surface of the Earth is constantly being reworked. And that means that anything resting upon that surface is, by its very nature, temporary. We can begin with the simple process of weathering. Rain, wind, frost, and heat all work together, slowly chipping away at anything that is exposed. Cliffs erode, grain by silent grain. The roots of trees push their way through solid concrete. Metals oxidize and turn to rust. It does not take long for buildings to become ruins, and it takes even less time for those ruins to become barely distinguishable piles of debris. Unless these remains are preserved under very special conditions, they are as good as gone. Next, there is the process of sedimentation. Soil, sand, dust, and ash all build up over time. They accumulate layer by layer, burying whatever happens to be underneath them. Sometimes this process helps to preserve things, but it can also crush and distort them. The layers compress and eventually turn into solid rock. Organic materials are broken down or replaced by minerals. After a few million years, a buried city might be nothing more than a vague imprint. Tectonic activity is another key player in this process of erasure. The Earth's outer shell is not one solid surface. It is a patchwork of massive plates that float upon a slow-moving sea of molten rock. These plates collide with one another, pull apart, and slide past each other. When they do, they create earthquakes, raise up mountains, open new seafloors, and drag old ones back down into the mantle. This last process, called subduction, is especially important. It means that entire sections of the ocean floor are gradually pulled under the continents and recycled. Whatever was on them is melted down. It is not buried, it is erased. The average age of the ocean floor is only about 200 million years. This sounds ancient until you remember that the Earth itself is over 4.5 billion years old. Most of the planet's seafloor has been replaced many times over. If an ancient civilization had lived near the coasts, their traces would now be at the bottom of a tectonic plate. They would be slowly turning back into magma. Continental surfaces last longer, but they too are an imperfect record. Erosion wears them down. Glaciers scrape them clean. Volcanic eruptions coat them in thick layers of ash and lava. Forests come and go. Deserts migrate across the land. Rivers change their course over time. Even massive impact craters, scars left by asteroids, can fade over time. What looks permanent from our limited human perspective is often just the current state of something that is in constant, ceaseless motion. The Grand Canyon is often presented as a great geological archive. Its layers of sedimentary rock are stacked like the pages of a book. But that book is missing many of its chapters. There are gaps where layers were never deposited. These gaps are called unconformities. They are a stark reminder that the geological record is not complete. It is a patchwork that has been stitched together from whatever happened to survive. And survival is exceptionally rare. The fossil record, which we use to understand ancient life, is incredibly incomplete. Most organisms do not fossilize. Even for those that do, they are only found when erosion or excavation happens to expose them. It is not that fossils are common, and we simply have not looked everywhere. It is that fossils are incredibly rare, and most of them are already gone for good. If this is true for bones, it is even more true for cultural artifacts. With humans, whose artifacts are only tens of thousands of years old, we often find mere fragments. A flint knife, a piece of pottery, a post hole in ancient soil. Archaeologists must reconstruct entire societies from these scraps. So when we ask whether another civilization could have existed millions of years ago, the burden of proof is enormous. It is not just that we have not found their ruins. It is that the odds of anything surviving that long are already vanishingly small. And even if something did survive, it would have to be in a place that has not been subducted, eroded, or buried too deeply. Consider how we look for impact craters. Large asteroid impacts leave scars hundreds of kilometers across, but many of these craters are now hard to see. Over time they have been eroded, buried, or deformed by geological forces. Some are only detectable through gravity anomalies or subtle changes in the composition of the rock. Now imagine trying to find something much smaller than a crater, such as a city or a factory. Unless it was preserved in a perfect geological niche, it would be extremely difficult for us to detect it today. And preservation alone is not enough. Someone has to be looking in the right place, at the right time, with the right tools, and asking the right questions. Most paleontological digs are not looking for signs of intelligence. They are looking for species, for bones, and for ecosystems. They examine sediment layers for traces of life and extinction events, not for signs of roads or buildings. An object that does not look artificial might not be recognized. Even when we do find something unusual, the first assumption is not civilization. The first assumption is that it is a natural process. This is a reasonable bias. Nature is capable of producing very complex and structured patterns. Without surrounding evidence, it is just a curiosity. This is part of the reason why the Silurian Hypothesis focuses on indirect evidence. Instead of looking for buildings, it asks whether a civilization might have altered the Earth's chemistry. Even that is hard to trace because natural events can produce very similar changes. A volcanic eruption, a release of methane, or a mass extinction all leave chemical fingerprints. These can look similar to the effects of industrial activity. So the challenge is not just finding the evidence, but correctly interpreting it. And that requires a certain humility. Not because the idea of a prior civilization is likely, but because ruling it out completely requires more certainty than the planet allows. We think of history as a straight line, but the geological record does not care about lines. It cares about pressure, heat, erosion, and deposition. It rewrites itself constantly. Most of what has ever happened on Earth is gone. When people hear the word fossil, they often picture a perfectly preserved dinosaur skeleton. They imagine the bones arranged just so, as if the creature simply lay down and became stone. But real fossils are rarely like that. They are fragmented, partial, and compressed by the weight of the Earth. Finding them takes luck, very specific environmental conditions, and an immense amount of time. Fossilization is an exception, not the rule. The fossil record is one of the best tools we have, but it does not give us a full picture. It is like trying to reconstruct an entire movie from just a few still frames and a handful of scattered subtitles. For every single species we have identified in the fossil record, there are likely dozens or hundreds that have left no trace at all. Some never fossilized, some did, but their remains were later destroyed by geological forces. So when we talk about ancient civilizations, we must keep in mind that we are already working with a record that is full of blind spots. Fossilization depends on a delicate combination of many different factors. It depends on how and where an organism dies and what kind of sediment it is buried in. It depends on how fast that sediment accumulates. It depends on whether the site is geologically stable over millions of years. The odds are stacked against preservation from the very beginning. For most of Earth's history, the places where life thrived were not great for fossilization. Coastlines, floodplains, and forests were too active, too wet, and too exposed. Now imagine trying to preserve not just bones, but artifacts and infrastructure. The odds of survival drop even further. Even stone tools can be hard to date and identify if they are found out of their original context. A chipped rock might be a tool, or it might be just a chipped rock. And most technological materials simply do not survive in the same way that bone does. Metal corrodes and fabric decomposes. Plastic breaks down. This means that even for our own ancestors, the record is frustratingly incomplete. Take Homo erectus, a species that existed for nearly 2 million years. We have their tools, their bones, and some evidence of their use of fire. But so much of what they did is completely unknown to us. They traveled widely and adapted to different climates. They likely had forms of communication, but we do not know what they believed or how they organized themselves. When we dig into the fossil record, we are digging into the survivors. We find the lucky ones whose remains happen to fall in the right spot, under the right sediment, away from too much pressure or too much heat. This is why periods of mass extinction leave such distinct layers in the rock. There is often a sudden die-off, which means a lot of material gets buried very quickly, with less time for decay to erase the evidence. The layers where we find the most fossils are often records of moments of crisis, not moments of flourishing civilization. So we might only find a past intelligent species if they lived near one of these rare, fossil-friendly zones. And what if a civilization advanced to the point where it stopped leaving biological remains entirely? What if it disposed of its dead in ways that do not promote fossilization, such as cremation or sea burials? We do not know if it is possible for life to evolve into something less physical, more distributed, or less organic. But if it were, the fossil record would not just be silent on the matter, it would be completely irrelevant. Even now, most of the matter involved in our own day-to-day lives is synthetic and non-organic. A future geologist might find layers of strange polymers, rare earth elements, and metal alloys. They might not recognize them as the remnants of a civilization. Imagine finding a thin layer of titanium dust in a 100-million-year-old sediment core. It might raise some interesting questions, or it might simply be dismissed as an unexplained anomaly. Interpretation is as important as observation, and this brings up something that is often overlooked, and we must consider the matter of bias. There is bias not just in what gets preserved, but in how we choose to analyze it. We often see what we expect to see. The idea that a civilization might have come and gone millions of years ago does not fit comfortably into most of our scientific frameworks. So unless the evidence is truly overwhelming, it is likely to be classified as natural variation. This is not because of negligence, it is because that is how science works. It prefers the simplest explanation that fits the available evidence. And ancient, vanished civilizations are not simple explanations. Still, we have other tools at our disposal. We have more than just bones and artifacts. We have signals and signs in the soil, in the atmosphere, and in the chemistry of the rocks themselves, traces left not by bodies, but by processes. These are traces left behind when something starts to change the very planet that it lives on. This is what happens when intelligence leaves a fingerprint, not through its tools or cities, but through its chemistry. As we have discussed, two scientists named Gavin Schmidt and Adam Frank posed a question that was both speculative and scientifically grounded. They asked if an industrial civilization existed millions of years ago, would we be able to detect it? They were exploring how science would even begin to look for such a thing. Their hypothesis is not about science fiction, it is about testing the limits of geology. It is about asking whether our own impact on the planet is truly unique. The premise is a simple one. If an industrial civilization like our own had developed 50 or 100 million years ago and then vanished, what traces would it leave behind for us to find? The scientists began with what we already know. Our own civilization is leaving geological fingerprints. We are changing the composition of the atmosphere. We are altering the chemistry of the oceans. We are depositing synthetic materials like plastics and pesticides into our soils and sediments. And these are long-lived global changes that are being recorded in the Earth's layers right at this very moment. So the question then becomes, what kinds of changes are the most durable, and would they look any different if they were created by an earlier civilization millions of years ago rather than by us today? One category of evidence is geochemical anomalies. These are changes in the ratios of stable isotopes such as carbon, oxygen, and nitrogen. For instance, the burning of fossil fuels changes the balance of carbon isotopes in the atmosphere. This distinct chemical shift gets preserved in sediment layers and in ice cores. If something similar happened in the distant past, it might suggest an industrial process, even if the civilization itself is now long gone. Another category is synthetic materials. Our modern world produces plastics and chemicals that do not occur in nature. Many of these compounds degrade very slowly. In theory, they could survive for millions of years in some form. Tiny particles of plastic, known as microplastics, are already appearing in the most remote sediments on the planet. They are found on deep ocean floors, in polar snow, and within high-altitude soils. Some studies suggest they could remain intact for tens or even hundreds of thousands of years if they are preserved under the right conditions. There is also the matter of fossil fuel use. Industrial civilizations require vast amounts of energy. If a previous one burned carbon-based fuels, that activity would release not just carbon dioxide, it would also leave behind coal ash, fly ash, and other distinct byproducts. These could accumulate in layers and might still be detectable. Then there is the issue of mass extinctions. Human activity has already accelerated extinction rates for many species. This kind of biological signature, a sharp and sudden drop in biodiversity, can leave a visible mark in the fossil record. If something similar happened in the distant past without an obvious natural cause, such as an asteroid impact or a massive volcanic eruption, it might hint at the actions of an industrial agent. But this is where things become especially tricky. Many of these same markers could also be caused by entirely natural processes. For example, about 56 million years ago, an event known as the Paleocene-Eocene thermal maximum saw a rapid rise in global temperatures. It left behind some of the same geochemical fingerprints that we are producing right now. Yet, as far as we know, no civilization was involved. So, how can you tell the difference between a natural event and one caused by intelligence? That is the most difficult part. The Silurian Hypothesis does not claim that we have found definitive proof of a past civilization. It asks whether we would even recognize that proof if it happened to exist. And more importantly, it asks us to think about what traces we ourselves are leaving behind and how long they will truly last. Even our most enduring markers are not guaranteed to survive for tens of millions of years. This forces a necessary shift in our thinking. Instead of searching for traditional ruins, we need to think like planetary archaeologists. We must look for subtle and indirect clues for chemical shifts and for disruptions in ecological patterns. The hypothesis does not tell us that someone came before. It just tells us that if someone did, their traces would be exceedingly hard to find. It gives us a starting point to think about what to look for and what it would all mean. If tomorrow every human being on this planet were to vanish, what would the world look like? What would remain a year from now, or 100 years, or a million? It is a grim but oddly useful thought experiment. It helps us to understand what kind of trace a civilization like our own truly leaves behind. In the first few days, not much would change, but very quickly, without human oversight, our systems would begin to fail. Power plants would shut down. After just a few years, nature would begin its slow work of reclaiming our cities. Plants would grow through cracks in the pavement. Animals would return. The line between the wild and the built world would begin to blur. Within a few decades, many buildings would start to collapse under their own weight. Steel would rust and concrete would crack. Roads would break apart. Satellites in orbit would begin to fail and burn up in the atmosphere. After about 1,000 years, much of what defines our presence would already be unrecognizable. After 10,000 years, even the scars of our cities would begin to fade. Forests would reclaim what was once theirs. So then we must ask, after a million years, what would survive? The answer is not much. Perhaps a few artifacts in stable, dry environments. Perhaps some synthetic molecules that resist degradation. These would be the real fossils of our civilization. Not buildings, not monuments, but chemical echoes. The planet would begin erasing us almost immediately, not maliciously, just mechanically. The usual processes of geology would continue. And in time, the idea that we had ever been here at all would become harder and harder to prove. If our own global civilization could be wiped away so thoroughly, how could we expect the traces of any earlier civilization to have fared any better? Some of our most persistent markers are not the things we built, but the things we changed. The carbon we released into the air, the nitrogen we added to the soil, the isotopes from nuclear testing. These are planetary modifications. Imagine you were a scientist millions of years in the future, digging through a core sample of ancient sediment. You see a thin, strange layer with higher levels of carbon, a drop in biodiversity, and traces of synthetic compounds. You might ask yourself, what happened here? Was this event a natural one, or was there something else at play? By imagining our own disappearance, we get a clearer sense of what kinds of evidence can actually endure. Geologists do not speak in years the way the rest of us do. They speak in layers, in thicknesses of sediment, in isotopes, and in core samples. Deep time tells you what is written in the rock itself. Most of what we know about the Earth's past comes from the chemistry and structure of these sediments. Each layer offers clues about what the planet was like at the time it was deposited. This is the language of deep time. It tells us about the climate, about the atmosphere, and about what kinds of plants were growing. It can even tell us about catastrophic events, and in some rare cases it hints at something much stranger. The proposed geological epoch marking human influence is already leaving a fingerprint. Future geologists will likely see a spike in carbon dioxide, a drop in biodiversity, and fallout from nuclear testing. This thin line in the Earth's crust will stand out against the background rhythm of the prior ages. It is not a full story, but it is a disturbance. It is a marker, and that is exactly the kind of thing scientists are trained to notice. So if an earlier civilization had changed its environment in similar ways, we might expect to find comparable signals, but interpreting them is another matter entirely. For every spike in carbon, there are natural explanations. The planet has its own vocabulary of disaster. It is easy to misread the source of an anomaly if you assume all causes must be natural. This is why context matters. It is not enough to find a single chemical signature. The deeper into time we look, the fewer tools we have to achieve certainty. Rock is durable, but it is also changeable. Signals get scrambled over time. Layers disappear. Nothing stays clean for very long. Still, some signals are stubborn. There are isotopes that decay so slowly they act as time markers for millions of years. If a civilization affected the world strongly enough, those effects might show up here. Even now, scientists occasionally find unexplained anomalies in the geological record. Most are eventually attributed to known natural causes. Some, however, remain unexplained, sitting quietly in the scientific literature. Science needs patterns, not just single data points, and that might be where the traces of an ancient civilization would sit. They might be hidden in plain sight, misfiled as a purely natural event. To say something intelligent did this is a bold claim. It requires not just unusual data, but a framework to explain why intelligence is the most likely source. Without that, even a correct hypothesis would likely be ignored. The language of deep time is real. It is there in the rock, in the chemistry, in the slow rhythm of sediment and isotope. It tells us what changed, and roughly when. But it does not always tell us why. That part requires interpretation. Some things vanish quickly, others hang around a little longer. And then there are things that can outlast civilizations, not because they were meant to, but because they happen to resist the forces of decay. One of the most persistent markers a civilization can leave behind is not its architecture, but its chemistry. When we mine metals or burn fuels, we are changing the planet in ways that can be written into the layers of the Earth. We also have to consider the ocean. The ocean does not preserve secrets, it breaks them down. It scatters them, buries them, and scrapes them away. It is a relentless editor, erasing nearly everything that it touches. Today, most major cities are built near coastlines. This makes them vulnerable. Coastlines shift, sea levels rise and fall, and in geological terms, the oceans move dramatically. Over the last 20,000 years alone, sea levels have risen over 100 meters. This makes the search for any ancient coastal civilization inherently difficult, not because it is implausible, but because those are precisely the regions that have been erased, buried, or made inaccessible by the sea. And when geology runs out of layers, what is left are the stories. Myths and oral traditions have been passed down through countless generations. Most are changed in the telling, but they persist even when buildings fall. Cultures all around the world have myths about great floods, about fires, and about stars falling from the sky. They describe golden ages that ended suddenly, and they speak of islands that were swallowed by the sea. Taken separately, each story sounds like symbolic fiction. Taken together, they begin to form intriguing patterns. One of the most persistent themes is the flood. It appears in Sumerian, Greek, Hindu, and biblical traditions, among many others. There is also geological evidence of dramatic sea level rise and coastal flooding, especially at the end of the last ice age. The people who lived near those coasts would have seen their world vanish. Their descendants may have told stories about it. None of this proves that an earlier civilization existed, but it does complicate the idea that our history begins with writing. The absence of a script does not mean the absence of memory, and stories can last for thousands of years. Then there are the so-called out-of-place artifacts. These are objects that have allegedly been found in geological layers that predate human history. Examples include metal spheres in billion-year-old rock or carved objects found in coal. Almost all of them have been explained as misidentifications, hoaxes, or natural formations. But the persistence of these stories tells us something. People are hungry for a narrative where civilization is much older than we think. The deeper you go into the past, the harder it becomes to prove or disprove anything with certainty. If a technological object were buried in a layer 10 million years old, we would probably assume contamination. And most of the time that would be the right assumption. But that same assumption, though statistically sound, makes us almost blind to the rare cases where it might be wrong. And we must remember that a civilization could exist without ever needing metal. For most of our own species' history, we lived without it. We crafted stone tools and built with wood and bone. We used fire and developed rich oral traditions. A civilization that built entirely from biodegradable materials could exist for thousands of years. And it could leave behind almost nothing that we would recognize in the geological record. A forest could grow over it in a single decade. In that case, its success becomes its invisibility. We tend to think of progress as a trail of artifacts. But the absence of those artifacts is not always evidence of a lack of progress. Sometimes it is a decision. So we are left with this. Where are they now? If they were here, why is there no memory of them? No whisper, no lineage? Did they vanish, or did they simply end and leave behind a record too faint for us to ever recognize? The Earth is not a forgiving archive. It is an active planet, always in motion. The disappearance of physical things is only part of the problem. What we are really asking is why there is no clear cultural thread. One answer is simply a matter of scale. Human civilization as we know it is just a few thousand years old. Now imagine a civilization that lasted just as long, but did so 50 million years ago. A few layers in the sediment would be all that is left. They could have ended suddenly, or they could have simply left, not for space, but for silence. Maybe they recognized that expansion has its limits. Maybe they chose not to build monuments, but to blend in with their world. In that case, they might have erased themselves so cleanly that we would never know they were here at all. This is the humbling possibility that intelligence is not unique, that it can arise more than once, and that it can vanish. We tend to think that if something important happened, it would be obvious. But that belief assumes that permanence is normal. It is not. The vast majority of even recent human history has been lost to time. Extraordinary claims require extraordinary evidence, and so far, there is not any. No machine parts in ancient rock, no coded messages in carbon layers. But an absence of evidence is not evidence of absence. The scale of time is so large that silence becomes the dominant feature. Not because nothing happened, but because the Earth is so very good at forgetting. We do not know if we are the first. We may never know for certain. And if we do find proof, we may not recognize it for what it is. It takes a great deal of effort to see a pattern that does not already match one we have studied before. This limitation is not just scientific, it is also emotional. If we accept that something like us came before us and disappeared, it reshapes what we think of as inevitable. Progress becomes fragile. Civilization becomes brief. Intelligence becomes less of a crown and more of a chance. So here we are at the quiet edge of the question. Perhaps we are left not with certainty, but with stillness. And in that stillness, the question itself softens, not because it has been answered, but because it has been heard. We are the first, or maybe we are not. Maybe intelligence is a rare and precious thing, or maybe it blooms in hidden corners and fades before it leaves a mark. Maybe the Earth has carried more minds than we will ever know, each one flickering into awareness, shaping its time, and then slipping quietly beneath the next layer of dust and stone. We search because it is what minds like ours are compelled to do. We reach through time and through possibility. The same curiosity that sends probes to other planets also sends our thoughts deep into the past. We ask who else might have stood where we now stand, looking up at the sky, wondering and listening for an answer. And you, right now, wherever and whenever you are a part of that long, unbroken thread, a thread that ties our questions to the silence, and the silence back to the story. Sleep, too, is a kind of deep time. It is a letting go of the surface, a sinking into layers of quiet and vast uncertainty. Rest now, not because the questions are over, but because you have carried them far enough for one night. The past will wait.